Here we are in section 3-3 with exercises 19 and 20. Number 19, 2 points on a line are 4, 7, and 1, -2. Write the equation of the line. So we got to get the equation of the line first, and then find the y value when x equals 9. Okay, how do we write an equation of a line? Here's y minus y1 equals mx minus x1. That's kind of the no-think way. We just need the slope and one of the points to stick in. So let's first find the slope. That's good. So we get slope is y minus y over x minus x. We get 9 over, what is that? 9 over 3. So a slope of 3. Excellent. So that guy is going to go right there. We're going to have slope of 3. Yeah, let's put that in. So we're going to write the equation of the line right here. We get y minus, go ahead and pick that point. It better not make a difference between which point we pick. Y minus 7 equals m times x minus 4. All right, let's simplify it. Jump this 3 through, and we get 3x minus 12. Add that 7 over. That's important. So we get y by itself. We now have y equals 3x minus 5. Excellent. So that's the first part, that we now have x. We found the equation of the line. Now use this equation to find y. Alrighty, let's do that. Let's change colors just a little bit so we know what we're doing. It says when x equals 9. So we take x equals 9 and stick it in, and we get y equals 3 times 9 minus 5. So that's 27 minus 5 equals 22. So y is going to equal 22, so the point 9, 22 is on that line. And look at this. We just took a little bit of information, got us an equation that allowed us to find anything we wanted. We could have found any number of points off of here. That equation gives us all power. Love it. Okay, let's try the next one. Let's go down here to number 20. It says the number of lung transplants in year 2 after they were possible was 113. So they had 113 transplants in year 2 after they were possible. In year 12, there were 248. So using the points, year 2, 113, and year 12, 248 transplants, find the equation of the line. So we've got to do that first, and then predict how many were performed in year 16. So that's going to follow the same pattern as 19. Let's go ahead and use it. Let's find the slope first. And we have 100, let's go ahead and 248 minus 113 over 12 minus 2. And what does that give us? That's 135 over 12 minus 2 is 10. Divide those two, and we get 13.5 or 26 halves. Either one is okay. We'll use 13.5 here. All right, so 13.5, that's the slope. Now, interesting point while we're doing this is number of lung transplants per year. So that's what this rise over run means in the real world, is that an average of 13.5 more lung transplants were done every year through that time period. That's kind of a cool thing. All right, so now we have the slope. We can now put this in, and we can use either one of these points. So we get y minus y1, 113, equals m, 13.5, x minus 2. All right, let's jump that in and simplify it, and we get 13.5x minus 13.5 times 2 is 26. And then go ahead and add 113 to both sides to get y by itself. And we now have y equals 13.5x plus, what is that? 87 is what it looks like. All right, which is interesting. This intercept means in year 0, they started off doing about 87 of them. Don't know if that's medically accurate, historically accurate, but that's what this model here would then predict for us. So we now have an equation, which means, yeah, let's change the color slightly. We now have the equation. Highlight that guy. And now we can move on to make a prediction. In year 16, that means when x is 16, what happens with y? So we get y equals 13.5 times x, 16, plus 87. Oh, better put that other parentheses there. And let's go ahead and punch in the calculator. I'm going to punch it in on mine. You can punch it in at home as well. 13.5 times 16 plus 87. And we end up y equals 303. So that means year 16, we would predict, based on this information, it's 303. Cool. Excellent.